Welcome to lesson number 11 in my calculus tutorial series on the quotient rule of differentiation. The quotient rule, we can write the theorem out as if q of x is equal to, it's going to be a fraction, where n is the numerator, and d is the denominator. So then what we can do is to find the derivative of q with respect to x. That's d of x times the derivative of the numerator minus the numerator times the derivative of x, that quantity divided by the denominator quantity squared. So that's going to be our basic formula. So let's look at a simple example. So let's let q of x be equal to x cubed divided by x. Well, we know that's just equal to x squared. So we're going to just, really that's just x squared, and we know the derivative of dx of x squared is just 2x. So there's our simple example. And we know that from the power law. Okay, but now what if we did doing the quotient rule, where we let the numerator of x be equal to x cubed and the denominator be equal to x, and then from that we're going to get the derivative of the numerator is 3x squared. The derivative of the denominator is going to be just equal to 1. So now putting that in the formula, what we're going to get is d of x in prime of x minus n of x d of x divided by d quantity squared. So let's just substitute those in and see what falls out. Okay, so d of x is just x, and then we've got times a quantity 3x squared, because that's the derivative of n, minus x cubed, that's the numerator, times 1 is the derivative of the denominator, divided by the quantity x quantity squared. So writing that all out, we're going to get 3x cubed minus x cubed divided by x squared. That's going to be equal to 2x cubed divided by x squared. That's just equal to 2x. Okay, that checks. That's just what we just saw. So we did the same derivative of basically just x squared two ways and got the same answer. So that's a good thing. That's a simple example. Now let's look at another example, a little more complicated. Q of x in this case is going to be equal to 5x squared divided by the quantity 4x plus 3. In this case, n of x, the numerator, is 5x squared. N prime of x is just going to be equal to 10x. D of x is equal to 4x plus 3. And the derivative with respect to x of d of x is just equal to 4. Now putting that in our equation, q prime of x is going to be d of x n prime of x minus n of x d prime of x divided by the d of x quantity squared. Plugging those numbers, those equations in, d of x we know is just 4x plus 3. N prime is just going to be equal to 10x. Now minus, and then we have got n of x, which is going to be equal to 5x squared times the quantity d of x, which is 4. Now divide all that by d of x squared, and d of x is just 4x plus 3 quantity squared. So that is going to be equal to, so we've got 40x squared plus 30x minus 20x squared divided by 4 plus x, 3 quantity squared. So that's going to be 20x squared, just combining like terms, plus 30x divided by the quantity 4 plus 3 squared. We could probably reduce that a little further, but that's probably about the simplest terms. And so that's going to be the derivative of this function right here using the quotient rule, and then this formula that we developed just a while ago. Well, I hope you got something out of this video and learned a little about the quotient rule of differentiation and calculus. I want to thank you for watching, and don't forget to leave a comment. I always like to hear from you.